You know that single TV cable in your wall? Ever stop and wonder how it's even possible for it to deliver ridiculously fast internet? Well, today we're going to pull back the curtain on the unsung hero that makes it all happen. Let's get into it.
I mean, really think about it for a second. You click on a video, and boom. Data zips from a server, maybe halfway across the planet, through all of these crazy complex networks, and then somehow gets funneled right to you through that one little cable. How does that final leg of the journey even work?
Okay, so the answer is this piece of tech that I'm willing to bet you've probably never heard of, even though you use it constantly, every single day. It's called the CMTS, and you can think of it as the master coordinator, kind of like the ultimate traffic cop and universal translator for your entire internet connection.
All right, let's start with the big question, the basics. What in the world is a cable modem termination system, the CMTS?
So at its heart, a CMTS is this really powerful piece of hardware. It usually lives at your cable company's local office. They call it a head end. And its number one job? It's all about managing the absolute fire hose of data flowing between the huge global internet and the thousands upon thousands of cable modems just in your neighborhood alone. Here's another way to think about it if you're familiar with other tech. A CMTS is basically for cable internet what a DSLM is for DSL. It's that absolutely critical bridge that connects two totally different types of networks and makes them talk to each other.
Okay, so that's what it is, but how does it actually work? Let's trace the path of a single chunk of data on its journey downstream. That is, from the wider internet all the way to your screen. The CMTS really has two huge jobs. First, you can picture it as a super-fast mail sorter. It gets this massive flood of data packets from the internet and has to figure out instantly which packet goes to which customer. Then, it does something kind of magical. It translates all that digital data into a radio frequency signal, an RF signal. Why? Because that's the kind of signal that can actually travel over old-school cable TV lines.
And the scale we're talking about here is just mind-boggling. A single one of these CMTS boxes can handle the data for over 150,000 subscribers. Think about that. That's one machine coordinating every Netflix stream, every Zoom call, all the online gaming for a massive chunk of an entire city.
All right, so the CMTS has created this RF signal. Where does it go next? Well, it travels on what's called a hybrid fiber coax network, or HFC. And that name tells you everything. It means the signal speeds along super-fast fiber optic cables for most of its trip, and then, for just that final little bit, the last mile, it hops onto the coaxial cable that plugs into your wall.
And here's the last step. Your little cable modem sitting at home. Its job is to catch that RF signal. It then does the reverse translation, turning it back into digital data that your computer or your phone can understand. And poof, your movie starts playing. The craziest part? This whole incredible journey happens in just milliseconds. But wait, that's only half the story, right? It's a two-way street. What happens when you send something out? An email, a file, your video on a Zoom call? Let's take a look at that journey back upstream. And this brings us to something that I'm sure has frustrated pretty much everyone at some point. Why is your upload speed almost always so much slower than your download speed? Well, the answer is all in how the CMTS is designed to handle that upstream traffic. And it's really a relic, a holdover from a time when these cable networks were built for one thing and one thing only, delivering TV to you. Okay, I know this table looks a little technical, but don't worry, the main idea is actually really simple. Just think of it like this. The downstream path, the data coming to you, is like a massive multi-lane superhighway. It uses a big, high-frequency band and a really clever method to just cram tons and tons of data in there. But the upstream path, the data going from you, that's more like a narrow, single-lane country road. It's stuck with a much smaller, lower frequency, and it has to use a system where all the modems in your neighborhood literally have to take turns speaking. And that right there is the fundamental reason for the huge speed difference. Yeah, the whole network was just fundamentally built for one-way traffic, for downloading, for receiving television, not for sending a bunch of information back out. That's exactly why that upstream path is a smaller, way more crowded road, and that's by design. You've got all these modems trying to shout at the CMTS at the same time, and it's the CMTS's job to somehow manage that incredibly chaotic conversation. But of course, technology never just stands still, right? Our demand for data, especially upload speed, is exploding. So, thankfully, the CMTS is evolving right along with it. You know, to meet all these new challenges, the whole architecture has had to change. We started with these big all-in-one boxes. Then we moved to modular systems, where you could scale things up more easily. And now, we're even seeing virtual systems that are just software running on servers, and even remote units that push the technology physically closer to your neighborhood to get you faster response times.
The next big leap forward is something called CCAP. That stands for Converged Cable Access Platform. And the big idea here is to combine everything, the internet data and the traditional cable TV video, onto one single, super efficient platform. It's a game changer because it saves a ton of space and power, and it just makes the whole network simpler and way more powerful.
But here's the thing. No matter how much this tech evolves, one core principle always stays the same, and this quote really nails it. Your cable modem can't just talk directly to your neighbor's modem. Nope. Every single packet of data, whether it's going up or down, has to pass through the CMTS. It is and always has been the absolute gatekeeper of the network.
And all this leads us to a really critical question for the future. As we dive headfirst into a world of 8K streaming, virtual reality, and literally trillions of connected devices, can these invisible gatekeepers actually keep up with the demand? The way they continue to evolve, well, that's going to define the future of our digital lives. Thanks for joining me.